electron charge. They are called bivalent metals. First example of bivalent metals is the D-block effect. Filled, empty, or half-filled D-blocks are more stable than other combinations of partially filled D-blocks. For iron, our first guess of charges would be that it would lose its valence electrons and be +2. Its 3d6 is very close to a half-filled electron, so if we lose 1 from here plus the original 2, we get an iron +3. And it has the electron configuration of 3d5. Again, it's a half-filled D block, which is more stable than the 3d6 combination. Copper would also have a +2 charge because of losing its 2 valence electrons, which leaves it with a configuration of 3d9. 9 is very close to 10, so its other option is to basically promote 1 electron from the S to make 3d10. So basically it's like a 2-step process. It'd be 4s1, 3d10. So it only has this electron to lose. So it's a +1. Titanium would have a charge of +2 by losing its 2 valence electrons. This 3d2 is very close to a empty d orbital, so it can also be just the electron configuration of Ar and be a charge of +4. Remember, the number of electrons lost is the number of the charge. The other effect that contributes to bivalent metals is called the shielding effect. You may remember how crazy the diagram got with all of our different orbitals kind of all coming together. Those filled d orbitals can prevent the loss of the electrons. So again, I use that the lines going after the antelope on the Serengeti with more electrons kind of zipping around in here. It makes it more difficult for those s electrons to be lost. For lead, it has a electron configuration of Xe, 6s2, 4f14, 5d10, 6b2. Our normal prediction of its charge would be its 4 valence electrons would be lead +4. And again, a loss of s and p electrons. The shielding effect says that these 2 filled blocks prevent the loss of these s electrons, so the other charge would be lead +2, and we actually see this as more common than the lead +4 for most compounds that have lead in them. So we're losing just this group of p2 electrons.